Okay, so now we're going to do Joule's law experiment. In this experiment, electrons are going to flow through this conductor here. When this happens, collisions are going to happen between the fixed atoms of the resistor and the electric current. When this happens, heat is going to be released. The amount of heat released depends on the voltage, current, resistance, and time. This is what we call Joule's law. The purpose of this experiment is to determine the mechanical equivalent of heat. The equipment we will need for this procedure is the power supply, ammeter, voltmeter, calorimeter, digital thermometer, timer, the balance, and some ice cubes. The connection is established by connecting the power supply from the positive terminal to the ammeter, then from the ammeter to the calorimeter, and then back to the power supply. This is done through a series connection. The voltmeter is connected to the calorimeter through a parallel connection. So the first thing that you want to do is measure the room temperature using this thermometer. After you do that, take the inner cup out of the calorimeter and place it on the balance. Then you're going to mass that. After you do that, you're going to add ice water into the cup and take its new mass. After you do that, you're going to subtract the new mass from the initial mass to get the mass of the ice water itself. When that's done, you place it back into the calorimeter and turn the power supply on. Once you do that, you're going to want to adjust the knobs right here so that the current on the ammeter is going to read 5 amperes. When that's done, then you take your stopwatch and you start it and you take the initial temperature. Once that is done, after every minute you're going to take the new reading on the temperature. You're going to do that until the temperature of the water is about 5 degrees above room temperature. So right now we're going to graph the data. You're going to create a time versus temperature graph. Using the instructions from your lab manual to create the graph, you're going to find the change in temperature. Once you do that, you're going to find the mechanical equivalent of heat using the equation J equals I times V times delta T, all divided by mass times the change in temperature. The number that you should get should be close to 4.186 joules per calorie.